Morning students, let us continue with your chapter number 5. It's exercise 5.2. In this exercise we are going to discuss modulus and the arguments of the complex number. So the modulus of the complex number is, students, z is equal to x plus iota y, that is modulus of z, that is equal to, this is the square of the real part plus square of the imaginary part, its square root. Then students, by this way this modulus will come. Second is argument or amplitude of the complex number. Students, if we having the complex number z is equal to x plus iota y, the case number 1 is there when x and y both are greater than 0, means it lie in the first quadrant. So remember student, if this point P lie in the first quadrant, so what we can say, this tan alpha, that is equal to y upon x. Y upon x means imaginary part over real part, its modulus. In that case theta will come as equal to alpha here, students, where theta is the argument and we will find out the alpha from here, that is imaginary over real part, its modulus. Second is there z is equal to x plus iota y, where x is less than 0 and y is greater than 0. It lie in the second quadrant, students, and you know, in the second quadrant, if you will see students, in the second quadrant here, what you will say, tan alpha is equal to y upon x, where theta is equal to pi minus alpha. In that case this theta, that will come as equal to pi minus alpha. Whatever the angle is there, that is alpha, we will subtract this angle from pi, that will come as theta minus pi. You have to keep this one in your mind. While it lie in the second quadrant, theta will come as equal to pi minus alpha. Third is there z is equal to x plus iota y. Both students, x and y, they are less than 0, means it lie in the third quadrant, and in the third quadrant it will lie here. Then students, now in that case here is the alpha angle, because it lie anti-clockwise, so theta will come as equal to minus pi minus alpha. So tan alpha is equal to y upon x, theta will come as equal to minus into pi minus alpha, or we can say as alpha minus pi also, students. So let us come with the next one, that is equal to your fourth part, while it lie in the fourth quadrant, because in that case x is greater than 0 but y is less than 0, then tan alpha is equal to y upon x. In that case students, remember this theta, that will come as equal to minus alpha. Right students, now we will make the use of this concept while discussing the questions of the exercise 5.2. Let us come with question number 1 of exercise 5.2. So question is there, z is equal to 1 minus 1 minus, this is iota under root 3. Right students? So here the question is, we have to find out z, modulus of z. First part is we have to find out this modulus, that is equal to, I have told you, minus 1 its square plus into minus under root 3 its square, means square of the real part plus square of the imaginary part having square root. This is 1, this is 3 students, 3 plus 1 is 4, 4 root 2, that will come as equal to 2, means your first answer is equal to 2. Now I am coming with the argument. Now here is the argument, students. In case of argument, we having the complex number, you have checked that x is less than 0 and y is also less than 0, students, because both are negative. It lie in third quadrant. It lie in the third quadrant, and you know, in the third quadrant I have told you this theta, that is equal to minus into pi minus alpha. You have to keep this concept in your mind, but we are using in the third quadrant, right? So we will find out this tan alpha now, students. This tan alpha, that is equal to y upon x, means imaginary part over real part. So here is the imaginary part is minus under root 3, real part is minus 1, and its modulus, that will come as equal to under root 3. Right students? Now what you will do, this tan alpha, that is we have to check when this tan is under root 3, that is on 60 degree, so it will come as equal to pi by 3, right? So from there we will get the alpha, that will come as equal to pi by 3. Now we will find out this theta, that is argument here, student, that is equal to pi minus pi by 3, or we can say minus into 3 pi minus pi by 3, that is equal to minus 2 pi by 3. Right students? So therefore we have two answers now. One is this z, that is modulus is 2. This is 2 pi by 3 here, students. Now there is one more question is there. Z is equal to minus 3 under root plus iota. Second part is there. This part is same, students. There are two parts that is in your syllabus. I want to tell you, student, there is another question is there. We have to represent the complex number in the polar form. That is not in your syllabus this year. So we will not discuss this question. So with that question, your exercise, there are two questions only in the exercise 5.2. One I have done, one I have left for you. With that question, your this exercise is over. Thank you.